Hey everyone, this is Mr. Barnett, and this is a walkthrough video for level 3 of the Demographer project. This level is all about exponential models of growth and of change. Your learning objectives here are that you can understand and draw exponential models, and that you can apply exponential models to some real-world situations. Exponential functions are some of the most powerful and most interesting functions that we use for real-world modeling, and this video will show you a little bit how they work, and also explain how you can apply them to study your own population whose change you're trying to model. So let me start just by talking about exponential growth. We've talked about linear growth. What's exponential growth? Well, exponential growth occurs when a quantity grows by the same rate over time. So in linear growth, we were adding or subtracting. Here, when we talk about exponential growth, we are multiplying or dividing. So if you look at this graph here, as x increases by 1, we are multiplying each time by 3, right? Each time x increases by 1, we're not adding the same amount, but we're multiplying by the same amount. Our rate of change here is times 3. On a graph, that's going to look something like this, right? You see that we are increasing sort of slowly, and then all of a sudden we're increasing much, much quicker as we multiply by 3. So we see a really rapid increase over time, often surpassing the increase caused by linear growth. And as an equation, we notice that the variable here is an exponent, 3 to the x power. So if we look at this, to find any value, we take our starting value, which is 2, right? And we just multiply it by 3 to some power of 3. So 2 times 3 to the first power, 2 times 3 to the second power, 2 times 3 to the third power, and so on and so on. Exponential functions also have something called a horizontal asymptote. That's a line that the function approaches but will never cross. So if we looked at this function and we were to zoom in, we'd see this gets closer and closer to the value y equals 0, right? The x-axis. But it's never actually going to reach 0. There's no value of x here that will make this function equal to 0 or go below 0 to become negative. So we say that that is a horizontal asymptote. By default, this is the line y equals 0. So if you just see an exponential equation like this, we think, okay, the asymptote is going to be that line y equals 0. But sometimes we'll see an equation that looks like this. A starting value, k, multiplied by another term, a to the x, a base to the exponent, plus a constant, c. The asymptote here is always going to be the line y equals c. And you'll see examples of this. I also want to talk about a phenomenon called exponential decay. So things can grow by the same rate. They can also shrink or decrease by the same rate. And when they do decrease in an exponential fashion, remember x in the exponent, we call this exponential decay. So here's an example of exponential decay. Note that each time x increases, we are dividing by 2. And another way to talk about division by 2 is also to say multiplication by 1/2. And you see that we have a dramatic, pardon me, a dramatic decrease here, right? Decreasing quickly and then slowing down. And the equation for this here is f of x equals 1, note our starting value, times 1/2 to the x power. So we keep multiplying by 1/2 over time. This quantity is going to decay or shrink quite rapidly. And when does decay happen? Well, when the base, that's this number here with the exponent, in this case 1/2, has an absolute value between 0 and 1, we see quantities that decrease. Remember, absolute value just means the number, but always positive. So when we're talking about a fraction or decimal smaller than 1, right, we're going to see quantities decreasing over time. And the best way to analyze any exponential function, by the way, is to graph it. You should have a graphing calculator by this point. And when you know how to graph functions, you can analyze them much more easily. So let's take a minute for me just to plug you to improve your graphing display calculator skills. Your calculator is going to be extremely helpful for this topic, especially for modeling problems. And the reason that is that it's hard to do exponential calculations in your head, right? Or on paper, they're hard. So use your calculator. Here are the things that you can do, practice, and I have these videos in the overview document, right? Your calculator skills videos. Make sure you know how to graph exponential functions. Make sure you know how to find the intersections of exponential functions with other functions. And make sure you know how to use a table of values to answer modeling questions, right? All those things are going to be very helpful to you. Okay? The calculator is a powerful tool if we know how to use it. If we don't, it's useless. So make sure you learn how to use it. It will serve you well, I guarantee it. Okay, here's what you can do from here. Take notes and answer practice problems in the level 3 companion. We're going to be working with these kind of note-taking aids from now on. You instead of taking notes on the computer, right? Take your notes here and answer the practice problems. If you're confident with every practice problem, you have achieved mastery of the learning objectives. To help you build your skills, again, I have some Edpuzzle videos and some Khan Academy practice assignments. Once you have the skills, you're ready to apply them by creating an exponential growth model for your chosen population, right? So here are the things you need to do. Find the average growth rate using an online calculator. This is linked in your level 3 document, by the way. Graph your model using Desmos or a graphing calculator, and predict your chosen population in 2050. This is the purpose of this project, right? To make some good predictions of population. Once you've done all that, review your work and complete the self-assessment survey, and you will have a good understanding of these powerful things we call exponential models. Thanks very much for watching, and good luck.